All right, everybody, welcome to the video here for lesson number 6 on perfect factoring. Now, I know some of this in class was a little bit tough. I know especially the new stuff. So before I actually do the homework, let's just review some things from the lesson. So first and foremost, difference of perfect squares. This is something we should know how to do. So if I had an expression like a squared minus b squared, that's just going to become a minus b, a plus b. I'm hoping there was no issues there. Difference of perfect cubes. So if I have perfect cubes, I'm going to have a minus b, a squared plus ab plus b squared. So I'm trying to figure out what cubed minus what cubed. So what are the a's and the b's here? With cubes, I can also do sums. I can't do that with perfect squares. I think we made that pretty clear in class. So I have a cubed plus b cubed. So that's going to become a plus b, and then a squared minus ab plus b squared. If you know those three separate formulas or processes, you'll be good for this homework assignment. So you can always refer back to those. So let's take a look at the first one. X to the fourth minus 81. So that I can factor to x squared minus 9 and x squared plus 9. Right, x squared times itself makes x to the fourth, so we can do difference of two squares. But I'm not done. I can still do that here. So that becomes x plus 3, x minus 3, and then x squared plus 9. The second one here is kind of an interesting one. This is actually a difference of two squares question again. I'm squaring something and I'm squaring something. So I would make two parentheses. The first one would be x minus 1 minus 2. And the second one would be x minus 1 plus 2. Just as if that was an x minus 1 if it was a squared. Then I can combine some like terms. So I have x minus 3 and x plus 1. Next one, y cubed minus 125. This is the same thing as me saying y cubed minus 5 cubed. So then I'm going to put into a parenthesis y minus 5, y squared plus 5y plus 25. Just following the pattern and the rules from the before. For the next one, I have 3x cubed plus 1 cubed. So that's going to become 3x plus 1, 9x squared minus 3x plus 1. The 9x squared comes from me squaring 3x. Number 3, factor x to the 6 minus 1 completely. Here you can do one of two things. You can either do difference of two squares or difference of two cubes. Difference of two squares will generate the answer quicker and easier, so you don't have to worry about doing much else work. So let's do difference of two squares first. So if I do difference of two squares, I'm going to get x cubed minus 1 and x cubed plus 1. Unfortunately, both of those still can be factored. So x cubed minus 1 is going to become x minus 1, x squared, sorry. X squared plus x plus 1. And x cubed plus 1 is going to become x plus 1, x squared minus x plus 1. Number four, I see a GCF. The GCF in this case is 2x, which is going to factor us out to a 64x cubed plus 27y cubed. Now, if you think about what's in that parenthesis, you can say that there are certain things that are cubed to make those terms. So I can say 4x cubed plus 3y cubed. That's what we're doing like mental math, I'm hoping, right? So this 2x is just going to hang out outside. So we're going to get 4x plus 3y. We're going to get 16x squared minus 12 xy plus 9y squared. Nothing else is factorable, so we are done. Show that x plus 2 is not a factor of x to the third minus 8. Explain your reasoning. So if we find that using synthetic division, that this comes out to have a remainder, that would tell me that this is not a factor. Remainder. So that means x plus 2 is not a factor because x cubed minus 8 divided by x plus 2 has a remainder. Therefore, x plus a is a factor of x cubed minus a squared. The answer to that is no, it's not. I could do the same thing with a, so I could say negative a, 1, 0, 0, negative a cubed. Again, we're going to wind up having something here where we have a non-factor. We have a remainder again, same reasoning. Number 6 says compute the quotient. So we're going to put a 2 here in our jail. 1 for the 5th term, 4th term, 3rd term, 2nd term, 1st term, and constant term. Look at all of those zeros. The 1 comes down, so we have a 2, we have a 4, we have an 8, we have a 16, not yet. And we have a 32. No remainder. So this answer is constant term, 1st, 2nd, 3rd, 4th. So I have x to the 4th plus 2x plus 4x squared plus 8x plus 16. So then it wants us to make a conjecture. Notice when I divided this out, I got all positive numbers, which is good for us. So the conjecture is going to be x to the 5th minus a to the 5th is going to be equal to x minus a. Why minus a? Because that's what I divided by when I got this other factor. Then a in this case was negative 2 or positive 2. So the first term was just to the 4th power. There was no a there. The second term had an a, so it's plus a x to the 3rd. The second term was a squared x squared. Why a squared? 2 squared is 4. The next term would be a to the 3rd x. Why a to the 3rd? 2 to the 3rd power is 8. And the last term was a to the 4th. Remember, we keep talking about patterns. Look at the pattern. The variable on x goes down as the variable on a goes, or the exponent on a goes up. So that means I should be able to factor something like x to the 5th minus 243. 243 I can change to the 5th power by saying 3 to the 5th power. So that means I'm going to use what's up here in this box, but instead of a, I'm going to consistently put 3. So I'm going to put x minus 3. I'm going to put x to the 4th power plus 3x to the 3rd power plus, now if you notice it's a squared, so that would be 9, x to the 2nd power. Then it would be 3 to the 3rd power, so that would be 27x plus 81. There's your factoring. If you don't believe me, multiply it all out and check it. Number 8 says to compute the product of x squared plus y squared squared. Now remember in class we said that we could do this mentally, right? But this does say show all of your work. So let's show some work. X squared, y squared, x squared, y squared. So we have x to the 4th, x squared, y squared there, x squared, y squared there, and a y to the 4th. These combine to give us 2. So I have x to the fourth plus 2x squared y squared plus y to the fourth. I think number 9 we did before. Let me just check that. Wasn't number 9 in a homework assignment we've already done? Let's go back a little bit here. Let me see. I could have swore we did that one before. Maybe not. That might just be crazy. I guess we didn't. All right, so let's do that one. My fault. I thought it was a homework assignment. All right, so this last one in the homework assignment tonight, first thing we want to do is we want to do the subtraction. So if I do 3x squared minus 1x squared, that's 2x squared. Negative 2x minus 3x is negative 5x. And 5 minus negative 2 is plus 7. And then I want to multiply that whole thing by 1/2 x squared. Well, 1/2 times 2 is 1, so that just becomes x to the fourth. 1/2 times negative 5 is negative 5/2 x to the third. And 7 times 1/2 is 7/2 x to the second. If you're not so great with fractions, use your calculator. If you did it with your calculator and you left it as decimals, you would have had this answer, which is totally acceptable too. Hopefully this video helps. Sorry it was a little bit longer than normal, and good luck with your homework.